Gonna babble a few things.
Hello, everybody.
Hope they can hear us.
Yeah,
Oh,
hey, there's a thumbs up. There
Very
we go.
good. That's what we like to see. All right, good morning, everyone. Thank you for coming to this session on the ideal serverless architecture. We're going to be speaking to you today about ideal, about serverless, about architecture, and so much more.
Next slide. There we go.
There we go. But first off, who are we? G'day, everyone. My name's Michael Gondolaris. I'm a platform engineer at Deloitte Consulting. I'm joined by my wonderful colleague here.
Hello, everybody. Obviously, I'm the other guy on the slide. I'm Fons. I'm a security engineer at Deloitte.
Now, we're both from Deloitte. Deloitte, amongst many of you, might not be a name that you might have immediately associated with AWS, with speaking at a tech conference like this. You might have associated it more with accounting, audit, risk compliance, things like that. But we also have a very strong engineering practice. We do a lot of cool engineering products with our clients on cloud, and that's what we're here to talk to you about today. Some really cool work that we've done with one of our clients, Currence Ideal. Cool. So this is what we're going to be talking about today. First off, we're going to start off with a bit of an introduction, talking about Ideal, the payment method here in the Netherlands, a bit about what it looks like, how it works, and then where AWS serverless components fit in to that picture. But really, one of the big things we want to focus on in this talk is about serverless. It's about our journey to serverless with Ideal, the journey that we went on building out this infrastructure, and to really share with you the lessons that we learnt along the way, and to share a whole range of tips and tricks that we learnt, which we hope to share with you so you can do that on your own projects, customers, and hopefully give you some inspiration as well. Cool. So, a bit about Ideal. First off, a show of hands. Who here has ever bought anything online using Ideal?
Yeah, there we go.
Okay, I think that's
Almost everybody.
pretty much everyone.
Yeah.
That's pretty good. Well then, it may be as no surprise to you to know that Ideal is the leading payment method in the Netherlands. So last year there were, it was just over 70% of all online purchases in the Netherlands used Ideal. So it's very big. It's marked as critical payments infrastructure because of that. Now the standard has been around since 2005, and it's become the default method that people use here. And it has phenomenal reach. So for anyone that has a Dutch bank account, and now even some banks outside of the Netherlands, which is new and really cool, so it has almost 100% reach within the Dutch market, which is massive. Now, last year, there were over 1.3 billion Ideal transactions that run through the network. We had our highest day ever, actually last year, over 7 million transactions in a day, which peaked on Black Friday at over 400 transactions a second, which is a lot of transactions and a lot of data flowing through this system. Now, I said that the standard's been around since 2005, but the way that people use the internet, the way that we buy things online, has changed a lot since then. And Currence Ideal, which is the organization, of the brand owner of Ideal, has been in this process of renewing the Ideal standard, trying to make it a better customer experience for people, add new features to it. And on its journey, Deloitte has been one of its transformation partners helping it with that.
Right. Thank you, Michael. So, as Michael mentioned, Ideal has been going through quite a significant transformation, both in the architecture that it runs and what it's kind of trying to achieve for its clients. And a big part of the transformation was changing the way really Ideal works as a network, where we went from a very peer-to-peer model, where these large banks usually talk to each other directly, to a more hub-and-spoke model, meaning there's a centralized Ideal processor. Let me try this clicker here. You can see over here. And a lot more in their ecosystem now. So the focus of our talk, what we're going to talk about today, mostly is these boxes that you see in green, the stuff that we built for the client to support the Ideal schema. Very specifically, it's the entrance point for Ideal, so where the clients connect and connect towards Ideal. It's a routing proxy. Now I'm going to talk a lot about this routing proxy later. So remember that. It will come back in the exam. And a schema checker and some data analytics. Schema checker being a method to check and validate whether all these parties in the Ideal ecosystem adhere to the schema that Ideal set. The standards as the data we expect coming in and the data we expect coming out of this processor. So we had a very interesting use case here where we had to support both synchronous and asynchronous traffic. Synchronous traffic being traffic going from these clients over here to the proxy, shipping off to this processor, going back to our proxy, and then we had the request and the response of this Ideal transaction, which we wanted to validate, where we could do asynchronous validation on this schema checker here. So it's very important here to remember that we supported both synchronous and asynchronous traffic in between Ideal processes and its clients. Now, final point here I kind of want to make. I know not everybody works in the financial service industry, so really quickly, let's talk about these people on top. These are the people that we're helping. Who are they? So we have issuers. Issuer is a bank that issues money. So if you're making an Ideal transaction, your bank will be the issuer. We have acquirers. Now, this will not be surprising. It's a bank that acquires money, right? So these will be the banks that are receiving money, banks like the Bank of the Web Shop. We have our CPSP, our Customer Payment Service Provider. These are things like Adyen or Molly, applications that help smaller web shops. And we have larger merchants. So these are the very big web shops that support Ideal. Think of a large web shop like Amazon, right? Big web shops that support Ideal. And really the scope of this talk are these three components here. But mostly, we're going to really dive deep into some of the technical lessons we learned and some of the cool tricks that we did using serverless.
Alrighty, so let's look at some architecture. It's an AWS conference. Of course, we're going to have some AWS services, some nice icons up here. So diving in a bit more to that picture, which Fons just went through then, this is what the architecture looks like. Again, some high level, but these are a range of the services that are used in there. So at the top there, again, we see those issuers, acquirers, CPSPs, merchants enter the ecosystem running through AWS CloudFront. It goes through WAF, it hits API gateway, and then hits a Lambda function. And then at that point, we go left to the Ideal processor for payments, and that's the synchronous stuff that Fons talked about. And then below that, we have all the asynchronous workflows, which is backed by Amazon SQS, and then it goes through to Lambda, to DynamoDB, and some other services there as well. So that's the sort of basic flow that we have there, and the basic architecture. Now, if we look at some of these graphs, this gives you a bit of an idea of a standard week of Ideal and what that traffic looks like. You'll notice a few things. It's very spiky. There's more transactions that happen in the middle of the day than in the morning, which may be of no surprise. But there's a few really cool things here. First off, the three graphs, the shape kind of looks the same, right? It's actually almost identical. You might think it's the same graph, just with different colors. But it's not. They're distinct services, but the same calls that are flowing through. So it looks like it's very it's just the same traffic, and it is, but it's really cool to see everything scaling up at the exact same points in time, which it needs to. So we have, this is our API gateway requests, our Lambda invocations, and our concurrent executions. But one of the things which I think is really cool to see is our SQS queue. So I talked before about synchronous, asynchronous. That's the asynchronous stuff there in the queue. Even when we have millions of messages that are flying around in this system, the maximum number of messages we have in our queue in that week is 7. And that's not because there's only 7 messages hitting it, there's millions, but the Lambda functions behind it are just hoovering up those messages incredibly fast and processing them. So it can handle that ideal scale very well, very quickly, and very efficiently. So when we think about that scale, it's really cool not having to think about when we have events like Black Friday or if particular web shops have big sales. We don't have to manually scale our infrastructure. This is all handled for us by AWS, which is super cool. There's a lot of work that we've done on maximizing the compute performance of our Lambda functions, which we're going to talk about in a minute. Also alongside high availability, multi-region failover. We'll get to that in a minute. But cost is also a very important consideration here with serverless, because we're only paying for what we use. We're not paying for being able to handle Black Friday loads at 1 o'clock in the morning. It's that seamless scale, which is why one of the key reasons why we identified serverless as being a really great use case for this, and the proof was really in the pudding, or in the eating. And finally, when we think about serverless and development speed, that was also a really cool thing. Using a lot of these AWS services meant that we're able to develop very quickly, able to prototype a design very quickly, and scale it up to production loads very fast, and just iterate on the designs as well. This was not our first picture of what we thought it would look like. We had a range of different designs, but we're able to prototype and build and change very fast. But let's dive into Lambda.
Yeah. So, 2 slides ago, I know it was a long time ago, I talked about this proxy and how important it was. It's good to remember here, this was a synchronous part of the ideal flow, which means that the faster we made this proxy, the less clients had to wait for their bank payments to complete. This proxy was in the critical flow of ideal transactions. And so it was, for us, very important to really try to reduce the latency as much as we could on this proxy. And like Michael mentioned, a really powerful part of serverless is this development speed idea. So what we did, we had a code base that was mostly Python already. As you can see on the top right, we have our little gopher with his Python pad. We're about to really dive deep into this rabbit hole, so we'll follow me around a little bit. We had most of our functions running in Python. Now, Python is known for a lot of things, not for its speed. Usually, Python is quite significantly slower than most programming languages. So we decided, hey, what if we tried a different programming language? What if we just prototype something new? That's what we did. We basically locked ourselves in a room for a week, built 2 versions of this proxy that we had to build for the client, and really prototyped it out. And it turned out that Golang was 30% faster than Python, which is quite significant. We ended up going with Go as well for building this. And it really helped us in a couple of ways. Michael mentioned cost. Serverless, one of the key points of serverless is pay for what you use, right? So the longer this Lambda runs, the more we have to pay. The faster we make it, the more efficient it will be. And it's also great for other things like power consumption, sustainability. It's all great. But we really wanted to optimize this Lambda as much as we could. So we spent quite some time in this project really going deep down into, hey, how do we really optimize our compute part of this system? And we also utilized the latest and greatest of Amazon, meaning the Graviton 2 processors. It's all in ARM, a little bit more power efficient and faster. In the end, it meant we reduced cost and we had a much faster proxy running that really helped out in the latency part of this problem. So our pro tip for this is, hey, if you're using serverless and you can use this really quick prototyping, try different languages. Try using really what fits for your use case. All right, we're about to go a little bit deeper now. Optimizing compute is actually kind of easy. It's just cycles on a processor and you really go deep into it, trying to optimize every CPU call that you make. However, people here who have engineered already will know that the hardest part to optimize is your network calls, especially when you're running on AWS, right? We can't go into the backbone of AWS and directly connect a fiber line between our SQS queue and our proxy. So we had to do a couple of really smart tricks to optimize our network calls as well. And to do that, we utilize what I think is a quite underrated feature of Lambda, which is Lambda extensions. So a Lambda is a little piece of runtime. You put your application in there and it will run, but it's only one process. And the problem is that when a Lambda invokes, it kind of forgets what the last invocation did and how it went. And also, it doesn't know if it's the last invocation. At some point, your Lambda will be cleaned up, and a new one will be spun up, which makes it very difficult to do things like retries. And what we noticed is as we started using SQS queues, when we tried to ship out our asynchronous traffic, so we got that request, that response from Ideal, and we wanted to ship it towards our SQS queue for asynchronous traffic, we noticed that sometimes the latency is really good, 10 milliseconds, 12 milliseconds, perfect. Sometimes it's not so great. Sometimes it's 20, 40, 50, sometimes it was 100. So the load time we added by shipping things to SQS would usually be very low, but sometimes be very large. Preferably, you would have a very aggressive timeout here. Say, hey, after 20 milliseconds, if you haven't been able to ship this message towards our asynchronous part of our system, just try next time. But this is very difficult in Lambda, because it doesn't remember what it did last time. It forgot. And it doesn't know if this is the last time it's going to try to do something. So an extension really works well here, because in an extension, you run this second process in your Lambda. You can simply tell the extension, hey, I have a message that needs to be retried on the next invocation. Next invocation, that extension will still have that message in your memory, and it will simply try again on the invocation. And the best part here is, an extension knows when it's the last invocation. So if something fails, if something really fails, and the Lambda is done, the extension still gets 2 seconds to do something. Now, 2 seconds doesn't sound like a lot. It just passed. But in computer terms, that's a lot of time, right? 2 seconds, you can do a lot of things. So the extension can, in the end, really try to empty out its queue. So what we built in the end is this part where we had to ship data towards our asynchronous system. We set a really aggressive timeout on it. We said, after 20 milliseconds, stop, send it to extension, and try again. The next invocation, the extension would simply try again, see if SQS is performing better now. And once your Lambda is completely done, it would empty out into entire retry queue if there's anything left, and try again. So in the end, we really optimized our network calls here as well, further slimming down the runtime of this Lambda, because if SQS was not performant, we would simply kill it and try again later.
Okay, diving a little bit more into the rabbit hole, what do you find? Canaries, canary in the coal mines. So Fons talked a lot about how the work that we do to optimize the compute of our Lambda functions. But how do we deploy them? Well, first off, when you think about software development, we always write tests. You write unit tests, you write integration tests, you do end-to-end tests, you do lots of tests. But there's no test like production. That's the one that really matters. That's your make or break. But as engineers, as DevOps engineers or SREs, we want to deploy multiple times a day. We want to always be able to push changes, fix things if they break, push new features, and deploy new versions. But when you're working with something that has some criticality behind it and it works, the temptation is not to touch it, to just let it run, let it do its thing. So how do we solve that problem between the criticality and wanting to be able to deploy more frequently? And canary deployments using AWS Code Deploy with Lambda, we found was the perfect solution for that. So how does it work? Well, when we want to deploy a new version of our Lambda function, it's run through all its tests, it's passed everything, it's green, we're ready to go. What do? Our infrastructure as code pipeline, backed by Terraform, runs, deploys a new version of that Lambda alongside the existing one, and then it triggers code deploy and says, hey, we're going to start to shift traffic. And it will just shift a percentage at a time. So we move 10%, we wait for a minute. If there's any errors, anything goes wrong, a CloudWatch alarm starts piping up, and then if there are errors, it will immediately roll back the deployment. And this is really cool because this gives us the confidence to be able to deploy knowing that we're not going to break production. We've had this trigger once in production, where we did push some code and we thought all the tests are green, it's all good. It wasn't. And it was amazing to see everything roll back almost instantaneously. We had almost no downtime as a result of it, which was super cool. And it's a very important fail-safe for us in that deployment process. It also integrates very neatly into our existing infrastructure as code pipelines, which is also really cool to be able to combine Terraform, our existing pipelines, with something like Code Deploy to manage those rollouts for us. Pro tip here, I think, if you're building with Lambda, I recommend using something like Code Deploy, especially if it has criticality behind it to manage those rollouts. But even if you're not, use aliases in Lambda. It might not be something you immediately sort of jump to when you're building with Lambda, but it gives you that possibility to be able to version them and manage those rollouts of versions. Even if you're not using Code Deploy, another tool, it will still integrate. So give it a go.
I was really happy to see that rollback, to be honest. Really happy.
So good. Okay, let's talk a bit about our deployment process. Because one of the really cool things, I think, about serverless is, and having a fully serverless environment, is that the idle cost of our infrastructure is almost zero. And that is really cool, because it means we can spin up and spin down environments with almost no cost. And if you think as a developer, if you're starting on a project, if you've joined a company as a developer, you want to have your own environment. And sometimes it can take a long time for those environments to be provisioned. It can be a real hassle. Sometimes you're sharing environments with other developers. That kind of sucks. So we started with this idea of, well, every developer should have their own environment. That's sort of a given. But because it's very quick for us to spin environments up, we thought, hey, why don't we just give every feature branch its own environment? So as developers, we work in feature branches like Git, but every time we push that code to a branch, it will immediately just spin up a whole new environment. That whole stack that we showed before will get provisioned, which is really cool, because it means that not just every developer gets their own environment, they get as many as they want. That's our basic workflow that we have. So as a developer, hey, it looks like me. That's kind of cool. So you develop in feature branches. It's called my branch. I do a git push. Our pipeline runs. And then using Terraform workspaces, it will provision all that infrastructure, and it just appends the name of our branch into the name of that resource. So API gateways, Lambda functions, you name it. So that's a really cool process we have there. One of the downsides it brings is you have a lot of infrastructure in your accounts. So one of the things that we had to do was actually build an AWS nuke pipeline to clean up these accounts. So once, twice a week, we have this pipeline that runs, which just completely nukes the account, wipes everything out of it, and then we can start fresh on a Monday morning, which is kind of cool, a whole new environment. And it gets us in this rhythm of being able to provision the whole stack and destroy it. Provision, destroy, which makes our pipelines very resilient. But also when you think about disaster recovery, if you want to spin up a whole nother stack in another region, actually, we're very good at doing that because we practice it every single day. Bit of a pro tip here. If you are implementing something like this and you're building with serverless, and I recommend you do it because I think it's neat, be aware of AWS service quotas. And usually when you think about AWS service quotas, it's about scaling or it's about provisioning resources. But you've also got to think about them in terms of deleting resources. We found there's all sorts of quotas on deleting like API gateways, custom domains, things like that. So we had to build in some very interesting retries into our pipeline to account for that. So that's one of my hot take. If you're doing this, be aware of those quotas.
Yeah, I always wonder if there's an AWS engineer somewhere who's like, why are these people deleting 100 API gateways every week?
Yeah, they're crazy.
What's happening? Who are these people? Cool. So, we've reached the end of our very deep technical talk. The Gopher has reached the promised land of serverless, and now it can truly enjoy the fruits of its labor. And one of the fruits of its labor is this multi-region deployment that we managed to do. So like Michael just mentioned, we were very good at deploying our infrastructure from scratch. And when we had to go multi-region, the only thing we really had to do is change an environment variable from one region to another and deploy our entire stack again. Remember that when you're using serverless, most of your components are stateless, meaning there's no state in the component itself. You just run a piece of code. Or maybe it's an API gateway with some configuration, or maybe it's an S3 bucket somewhere. But most of your configuration is completely stateless. So the only state we had to manage in this case was our DynamoDB, our database, so our data layer. Now, luckily for us, DynamoDB has a really neat feature. You can build global tables, and global tables can be replicated across multiple regions, which meant that for us, we could simply turn on this feature, replicate our data, the only stateful part of our stack, and start syncing data between these two regions. And all we had to do then was to redeploy our entire stack to a different environment. And we got really good at deploying our entire stack to a different environment. So it was surprisingly easy, to be honest, to get this done. There are some caveats, though. Engineers here will know that everything in engineering has a price. And also for going multi-region like this, as an engineer, you have to pay a price. The problem is data syncing between these two regions can take some time to properly sync. I believe it's maybe up to 2 seconds before data syncs. So you need to start thinking about, hey, what happens if a client, in between the 2 seconds, tries getting a hit on my database in another region? So there will need to be some engineering to do retry mechanisms, or maybe wait queues to make sure that when you have a miss in your database that should have been a hit, you can handle it on your technology stack itself. This can be quite difficult, and this is the price you have to pay. You do, however, of course, make a trade-off here. You say, hey, my application is a little bit slower now. However, it will have more uptime, basically, or better uptime. Of course, we're using serverless, right? Which means that in one region, we already have the benefit of 3 availability zones to use. So it should already have quite a significant high uptime. Applause for the stage next to us. It should have a quite significant and a good uptime. But if you want to take that step further beyond and say, hey, if the entire, I don't know, if the entire region of Paris drops, I still want to be able to run. Then you can start using this multi-region stuff. And serverless is a really good fit for multi-region, simply because most of it is stateless. And when you really focus on your automation and try to get really good at deploying and redeploying your serverless stack, implementing this becomes not trivial, but a lot easier. Just remember these costs that you have to pay for your database misses that should have been hits, or for your data misses that should have been hits. So our pro tip here is use latency-based routing. It's a very neat feature in Route 53 that you can use, where the DNS part itself will route your clients to the closest entry point of your application. Meaning, let's say, for example, I would deploy my application in America and in Europe. My American clients will be routed to America, and my European clients will be routed to Europe. What we notice in these cases is, hey, clients are usually geographically pretty close to the services or the clients or the ecosystem partners that they are using. So we will greatly increase your odds of getting a database hit. All right. And then an interesting point here. This is a lesson that we learned as we were using serverless. It's not really part of serverless itself, but we noticed that, hey, we have a lot less responsibilities now as engineers for building things. So here on the bottom, you can see what you should all know as AWS engineers, of course, the shared responsibility model. Everybody loves it. And it basically says, hey, what is AWS responsible for in my infrastructure, and what am I responsible for? And let's think about this for a second in the context of serverless. What are we still responsible for? Well, networking, obviously, AWS does the networking for you. Hardware, we don't have hardware anymore, right? But this is also the case when you're running VMs. Well, there's more components here now. We abstract away our operating system layer. So I'm a security engineer. Back in the day, I had to do patching, a lot of patching, and I hated it. I still hate it. It's very annoying. You have to go into your system, you do update, it doesn't work, some dependency breaks, it's very annoying, and it's just very tedious. I don't have to do patching anymore, right? I'm using Lambda for my runtime, which means it's all AWS managed. Bless them, I don't have to do it. Let them patch, right? They have scale, they have a lot of engineers, a lot more than there's in our team, obviously, and they can do it really well. So I shouldn't be responsible for that anymore. I'd like to really push away all those responsibilities. And what we noticed is that as we started really going all in on serverless and really try to build our entire stack, our entire infrastructure as a serverless stack, we noticed that we had a lot more room to do other things, basically, because our scope of responsibility really narrowed down to this very small scope of things we're responsible for. And now, the POs in the room will say that's perfect. It means you have time to build more features. Isn't that great? I say no. No, not more features. No, I see you, not more features. No. We should focus still on the non-functionals, right? We should focus on our non-functionals. We have less responsibilities now. We're still going to build infrastructure. We're still going to build applications as quick as we can. We're going to make cool features. But we have time to get really, really good at the things we are still responsible for, right? And what are we still responsible for? Well, our infrastructure as code, so our automation, our CI/CD. I think Michael already talked a lot about it, but we got really good at automating our systems. We had one deployment for our entire infrastructure stack, everything automated. So there's no manual work in between, right? We got to spend a lot of time on refactoring and optimization. I spent 2 slides and some very technical talk talking about how did we optimize our lambdas, right? How did we really improve the runtime of our system? And we had time to do that because serverless just took away all these responsibilities that we had that I no longer had to worry about. Security is something we got really good at. And I have a really nice use case here about how we used serverless to improve our security. In applications that you build, you always need some sort of key material. Some credentials to authenticate to a database, maybe private keys to authenticate towards APIs. And what we managed to do was use serverless to generate these credentials automatically for us. So we spent time to write code to automatically generate these keys. Now this is great because a Lambda is ephemeral. I'm really happy I said that word correctly. I practiced a lot. I'm going to do it one more time. Ephemeral.
Very good.
Amazing. So these lambdas are ephemeral. What does that mean? It means they're temporary. A lambda will run for at most 40 minutes, and after that, it's lost in the ether. It's gone and never to return. This is very important when you generate the key material. Usually, and I've been in these cases, you'll need to do a key ceremony. You lock yourself in a room for 8 hours straight. You type some commands on a very specific laptop that is afterwards shredded or burned or destroyed. And that way you can make sure that your key material never leaves the place where your keys are stored. And in this case, we used a Lambda, or we used Event Bridge here, scheduled event, to trigger a Lambda which generated keys for us and stored it in Secrets Manager. Now, as a security person, I really want these keys to only be in Secrets Manager and never leave anywhere else. How do I know that that went properly? Well, the Lambda is gone after 40 minutes. So the window of opportunity you have as, let's say, a nefarious actor to break into our system and get a key out of this Lambda is incredibly short. And it's also very difficult to do. So we managed to use these neat tricks to really improve also the security of our platform. And this was because we really managed to scope down our responsibilities and said, okay, we are only responsible for these parts of the application, and that's what we're going to get really good at. And we're really going to focus on going to do good at that. Final point I want to make here. It's going to be a bit managerial, I'm sorry, but infrastructure as code, in this sense, the way you use it, and serverless also means your operational overhead is incredibly small, right? There's no more patching. There's not a lot you have to take into account. So our ops team was also very small. And luckily, we almost never had to do anything in terms of maintaining these systems. So from a cost point of view, let's think about cost again. It was also very beneficial because you can use a very small team to manage a lot of infrastructure in the end, simply because they don't have a lot of responsibilities anymore.
Thank you. Okay. This is the last slide we're going to be talking about here, and a really cool pattern that we came up with that we wanted to share with you here, which is about how we manage access into our environment. And the flavor of this talk has very much been about serverless, and that theme sort of continues on with this, but this is a pattern that you could use in your AWS environment, which isn't just about serverless. If you have serverful architecture and infrastructure, you could definitely use this pattern to talk about here. So when we think about access into our environments on AWS, having a good time over there, we think about privilege of least, the principle of least privilege. So your users, developers should have the least amount of access that they need, the minimum amount to be able to perform their work. And access to production should always be as limited as possible. So we thought, wouldn't it be cool if we just locked ourselves out of production and that no one has permanent access to those environments? And the only way to be able to get that is through a pipeline. It's through an approval process, and you get temporary access into production. And there's numerous ways that we've thought about doing this with AD in the past and things like that, and it's always a bit clunky. But we found a really cool way to do this using AWS IAM Identity Center, formerly SSO. If you've worked with that, it's now IAM Identity Center, which is cool. So we have a pipeline that runs to be able to manage access into our environments. How does it work? This is our pipeline up here. There's me again.
It's you again.
Up the top. Now, the developer up there, I put in a request in our pipeline to say, hey, I want access into production. I link it to a work item ID, a user story, popping off. I put in who wants access, how long access for, and then that request is then sent to Fonz over there.
It's me.
Also in there, who gets to review that request. Let's say he approves it, or doesn't. Hopefully he does. And then the pipeline reaches its next step, and some Terraform runs, and it will create a permission set in IAM Identity Center. And this is a custom permission set that's mapped specifically to that user into the account which is requested, granting it access. And one of the cool things that we're able to do with that is add a custom permission on there that grants the access, but also using conditions, which is a feature of IAM policies. We can set a very explicit time frame on when that access is valid for. So when we say it's valid for an hour, it's exactly an hour. It's not a second over, which is really neat. So our pipeline creates that permission set. It's mapped to a user. The pipeline waits a certain amount of time, and then afterwards, it cleans up that permission set. But precisely because of those conditions in the policy, even if something was to go wrong in that pipeline, the access is already immediately revoked. So we have very explicit guarantees on how long that access is granted for. Also, when we think about traceability and auditability, there's two things that are sort of built into this pipeline which gives us that. The first one is everything you do in AWS is an API call, and that is all available through CloudTrail. So we get a full audit trail of what people have done with that privileged access into those accounts. But also, when we create the permission set and the role, it has that work item ID in there. So we actually have full traceability from the creation of a ticket or a user story through to a user being granted access and then everything they did on the environment. So from an audit and compliance point of view, it's really neat. Now, there's a lot more that can be said about this pattern, how we built this, example code, things like that. Fortunately, there's a blog available, so if you've liked this pattern and you think it's kind of cool and you'd like to implement it yourself, go and read my blog. It's up on Medium. There's a whole bunch of information there about it. There's some sample code in there as well, which you can try out. And always happy to talk about it afterwards as well.
All right, Michael. I can't believe we made it the entire talk without saying serverless is the ideal architecture for ideal.
We missed it.
We forgot. That's unfortunate. But this is the end of our talk. So we spoke a lot about some of the very neat tricks that we did. However, turns out for us 45 minutes was really short. If you have any more questions or want to talk to us, we will be at the Deloitte booth in the afternoon. I learned to always end with a call and action. So buy something with Ideal tonight, read Michael's blog, and thank you very much.